Hello everyone! You've unlocked a new video, and today I'm going to teach you how to use this little chemistry kit. And after this, you'll definitely understand what pigments are made of, why they look the way they do, and why they, for example, get removed through orange. Well, probably not through green, of course. Anyway, it's going to be very interesting. So in front of you, there's a kit that includes organic paints. There's titanium dioxide, carbon black, mineral paints, and 3 dry pigments. One of them is also organic, one is carbon black, and one is black iron oxide. And we also have 2 of our wonderful pigments that you can compare with the results of your own mixes. We've also got glycerin, propylene glycol, and yes, water. There's even a young chemist costume in here, which you really should wear, along with gloves so you don't end up like me, completely covered in carbon that's gotten stuck under my nails. So I won't be wearing gloves today, but I highly recommend you do. And there's also a little lab coat so you don't get your clothes dirty. At the very least, that's how it works at a conference. But even at home, if you want to play around with this kit, it's really fun. And here's this wonderful microscopic magnet that you can later use to see how it all works. Because, for example, black iron oxide is magnetic. And if you make your own mineral pigment, you can actually test any mineral pigment to check whether it's real or not using this method. Plus, it's a lot of fun to demonstrate this to your students, or even to clients. Everyone gets curious about magnets and black iron oxide. By the way, if you didn't know, red and yellow iron oxides are not magnetic. So this only happens because of the black one. What else do we have here? A couple of micro brushes, because they're super convenient for mixing. I always use them myself. And something every artist has, cotton swabs. We didn't bother to include them. And paper. Speaking of paper, let me show you a little magic trick so you understand how different types of paper can give the same paint different shades. Here's the exact same paint. Look, completely the same color. On sketchbook paper for drawing, it looks warm and soft. That's why I recommend smudging or testing all your colors on professional grade paper. The main thing is, don't use printer paper because it distorts the color, pulling it more toward the cool side. And under those conditions, you might think, well, let's say you just bought a new pigment. You might think it's cold or ugly. But in fact, look, here the browns are warm and beautiful, while here they look cooler. So just remember, paper can change the shade of pigment. It might even be worth testing on 2 different paper types, so you can see that the pigment isn't bad or too cold. It's just the paper affecting the perception. What is our goal? In general, to make this set, the one I showed you, so that you understand that good pigments should not only implant well, wear well, and fade over time without changing their shade, but they should also be removable in a tolerable way, so to speak. That's very important because right now there is a huge wave of removals. People are starting to get rid of those overly wide brows that unloving artists gave them as punishment. More than half of artists work in this technique. These huge brows wider than a finger beyond the natural brow line, using hybrid pigments, and hybrid pigments that are very warm. And that's bad because your clients will walk around with these unremovable orange residues for a very long time and maybe even hate you for it. Because now there's a trend toward narrowing brows. Girls are tweezing them down to thin lines again. That's why from the very beginning, I took care to make sure pigments could be removed in a wearable way. Even though they are organic, we'll do the dirtiest work at the end. I mean, messing with dry pigments. Look, brow pigments can be made in small capsules. We've pre-placed them here for you. But lip pigments, most likely, especially when you play with titanium dioxide, for example, or black or blue pigments that strongly distort the color, you probably won't be able to add a microscopic drop. Because in our lab, we work in large volumes, we prepare pigment by the bucket, and you can add just a little black compared to another color. But you'll be working drop by drop, and drops are all the same size. And a single drop of black pigment makes any color completely unacceptable, dirty. I mean carbon black. It's very covering, very strong. So you need to understand this. By the way, now I'll show you some little life hacks to make this easier. I recommend soaking cotton swabs in water beforehand. That way they absorb pigment better. You know, I'm sharing my little tricks with you. So let's start with the first thing. We'll make a mix from pure organic pigments. Here, by the way, let's take a big capsule. And let's take, for example, let's get out all these colors. Look, they're all beautiful. Each of them can be used on its own as well. Make sure to shake them really well. Look, this one is CI 12085. CI 112466 here, and this is actually a very beautiful color, and CI 112477. Actually, from these three colors, you can make an incredible number of shades for lips. By the way, these pigments are not for working on clients. Keep in mind, for working on clients, we have here two pigments that are packaged in sterile conditions, which you can use. These are real pigments mixed in the laboratory, mixed correctly, because you will actually understand now. And in the end, when you compare your mixes with those prepared in the lab, you'll realize that it's not only possible to mix pigments, but they also need to be mixed correctly and in the right conditions, and all that. So what do we do? To begin with, by the way, we also have here a sheet, which will also be included in your kit, where you can make swatches and actually see how they look, right? Because that's also curious. So, 12466, let's go. How do I prepare pigments? I am a professional artist, after all. First, I make all the swatches of the colors that the lab gives me. And only after that, I change their shades by I weigh them on special laboratory scales. This is not simple at all, actually. So, 12-466. Let's make a swatch. Drop literally one drop. You don't need much here, just enough to understand how the color looks. Look. Interesting point. Before I started working with pigments in the lab, I always thought that organics were exactly the covering type. But now, together with me, you'll be surprised when you understand that organics are actually not really covering at all. So 85. Let's do a swatch. We made these shaded fields for you on purpose so that you could see and understand that some pigments are covering and some pigments are not. 2477. There. Don't confuse them. Okay, I'll put them right here. Oh, you can't even imagine how fascinating this is and how stuck you'll get on this, on creating these pigments, on creating these new kinds of colors. Look everywhere, even from the very beginning where the density is maximum, all the squares show through. So what's the conclusion? If you are working with pure organics, for example, then they will always only be tonal. They will never cover freckles. They will never cover pigmentation spots. They will simply give a new color, blending with the natural color of the lips. Plus, since the colors are very sharp, what does sharp mean? You'll understand right now when I make swatches with minerals. It means they are really bright, juicy. That's always organics. They are immediately very noticeable. So let's do everything then. What's next? 21-108. Yellow organic. Open it. Yellow organic, the very one that almost never gets removed by laser. But, see, it's not covering at all. It didn't cover the squares at all. By the way, if you run out of this sheet, you can print out more. In the same place where my video lives, there are also all these drawings. Or you can just write directly on paper for yourself, CI, and the words covering or not covering. Well, like if you're teaching students. What do we have next? 7-266. 7-266. This is carbon. Carbon, the smallest particle, the most bright, the blackest, the most covering of all the pigments. You see? Right? Here everything is covered, nothing is visible at all. CI 21110, orange organic. By the way, now you can clearly understand when reading pigment labels what is what and how it looks in real life. Also, you see the color is sharp, but it is not covering, so titanium dioxide. Don't be alarmed that it will look a little yellowish pinkish here. This is the liquid component. It won't be visible either in the skin or anywhere else when you use it. Just some ingredients have a tint. These are ingredients needed to dissolve pigments. Let me tell you right away, the titanium dioxide here in the set is diluted because only very little is needed to create a lip mix. In general, titanium dioxide can't be used in large amounts anywhere, so we made it diluted so that it wouldn't whiten your mixes too much. So blue, 77510. If you have a laser, you can already try it. Click a little, see how it looks. Black and yellow mineral. Anyway, we'll grind all this now. Black mineral. Notice that it is very covering too. Yellow mineral. Look, the yellow mineral is so covering, unlike the yellow organic. And the red mineral, also quite covering. Here we have mixes, and here you can also make swatches of other colors of pigments you have at hand to compare, for example. Next, we will work on paper. So let's make a mix from the lip organic. Let's mix. We have already seen what these colors look like. Ideally, you need to count the number of drops to understand how much of each. Let's do 1, 2. And 1, 2. And let's see what we've got. We stir with this part, the back end. It mixes very well. Let's see what color came out and whether it covers. A mix, for example, 2 to 2. And you can write down the CI there, 12,466. Anyway, whatever, it's not important. Write it down if you want, or not. So, okay, we stirred it. We take a cotton swab and see what color we got. We soak up the pigment really well. And you can color like this and see whether it's covering or not. You see, all the letters show through. And right away we prepare, for example, a cooler mix, which we need. We can take, just for fun, let's take a new cap. If you're doing this at home, you have unlimited caps. Here I took 3 caps of a very warm red organic color, 12085. And I'll take blue. Yes? Let's see what we get. 1 drop of blue, stir. To avoid wasting it, I won't stick the cotton swab right in there. It will soak away too much pigment at once. You can just grind it and look at the shade. Well, it's something like that. Now I'm curious already, and I'll rub it out so that both the undertone and the main color are visible. So you can see, right? Here we have the bright part, and here the semi-transparent color. Already look what an interesting, dusty, noble shade we've got. Now I'll do the same thing, the same mix. I'll take again this warm organic CI 12477, let's say 3 drops, add 1 drop of blue, and let's shoot a couple of drops of titanium dioxide in there and see what mix we'll get. In the cap, it's not very visible, but it didn't really lighten enough. I want to make something lighter. Let's add 2 more drops. Remember, this titanium dioxide is already diluted. It will never look like plasticine in any case, because when we add titanium dioxide somewhere. First of all, it doesn't fade through green. This has been tested for years and thousands of procedures. And secondly, it's soft. There's not much of it in there. And now we make a swatch and see what color we got. Look, the same ingredients, yet such different colors, because here I had more blue. And well, plus the titanium dioxide, all this gives a completely different shade every time you mix something. Let's put this cap aside. Ah, I took the wrong color. Silly me. I picked a more red one. That's why it turned out differently. But now you'll see. 1, 2, 3. Again. Now I'll make this exact color. What a fool I am. 1 drop of blue and 4 drops of white. It's very important to take precisely the shade you need. Otherwise, you'll end up with an unpredictable mix. So here's this shade. Look at it, it's the same color, only see how much more covering it became, how much more opaque the gradient looks. So this is the same shade, but here it's without titanium dioxide, just 2 colors mixed purely. And here it's with titanium dioxide. And the result is a shade somewhat similar to our dusty rose. It's noble, muted, very interesting. All right, putting it aside. Okay, let's move on. We've done the blue. Now let's do lip pigments with black. That's another interesting experiment. Here, we'll probably take a bigger cap, and let's take 2 warm shades and do 1, 2, 3 drops of 12477 and 3 drops of 12085. We need to make a microscopic drop here. And that can be done like this. Let's experiment, right? Watch, I'll add 1 drop of black, and what do we get? 2 super bright, sharp colors and 1 drop of black that completely kills the beauty of these reds. That's it. Here you can see why starting like this. Well, it does become more opaque, of course, and this is already almost practically a brow color. Look at the shade. It's very dirty, kind of brownish violet. Now I'll warm this shade up. Let's add not this one, but yellow to neutralize that violet tone. I added 3 drops of yellow. And just like that, bam! We almost got a brow color out of lip pigments. Let's see what we've got here. Not exactly brow-like, but overall close to brow. But it's still kind of neither here nor there. You see, it's neither brown nor red. So we'll add more here. Let's add some more orange, organic. Ah, here it is, the orange. More orange. There was a red-orange shade, but this one is orange. That is CI 21110. Notice how much organic pigment is already in here compared to just 1 drop of black. That makes 3 drops, 3 drops. Already 12 drops total. My cap is almost full already, and we still haven't achieved the desired shade. Now it's already brown, even resembling some brow mixes, because many are made overly warm. Many manufacturers make them far too warm. So right now, we've got red, orange, and yellow organic pigments. 12 drops, maybe even more, I've lost count. And only 1 drop of black carbon. We can make a swatch of this color. I'll press the stick a bit so it absorbs, because there's a lot of pigment here. So we've got a nice enough brown color with a very, very warm undertone. This color can be made cooler or even warmer because after all, it is brown. Let's say we add a couple more drops, 3 more drops. So that's already about 15 or 16 drops to just 1 drop of carbon. And let's make another swatch. Still brown, see? Quite a beautiful shade, but look how it reveals itself with orange, almost red. You see that, right? So we're basically making brow shades now. What else can we add here? Let's add 3 to 4 more drops. You'll notice that this color will hardly change. Let's do it. 1, 2, 3. 3 drops of titanium dioxide, which enhances the covering properties of the pigment. But when it's only a little, it doesn't really make a big difference in terms of drastic color change, whitening, or anything like that. It's still the same beautiful brown shade. No one who didn't know titanium dioxide was added here would even notice. And manufacturers do add titanium dioxide. Good manufacturers do. In our pigments, it's included in just the right amount so that the pigments have coverage, so the color looks beautiful, doesn't appear dusty, and so that years later, when the pigment fades, it leaves without changing its tone and without leaving a base undertone. I have a huge statistical sample because since 2013, I've been producing pigments and testing them in my own studios. Remember, I had 11 studios across 9 cities. Schools, too. We've removed pigments many, many times, with 5,000 procedures a month, touch-ups, corrections, so yes, a huge statistical sample. I know how colors behave over time because no one else has had such a flow of clients, not a single manufacturer of pigments that exists today. So, okay, we made brow mixes on carbon, and we got about 1 drop of carbon to about 15 drops of organics. Yellow, orange, and red. Remember the proportions, okay? Meaning here we can only regulate by drops, of course, because we don't have scales or any kind of micro-dosing devices. So now we want to make another mix, but this time with, for example, iron oxide too. Let's take 2 warm colors. So again, I take CI12477, 3 drops. I'll always put 3 drops so it's easier to remember. And 1085, also 3 drops. 1, 2, 3. And I need black iron oxide. So I have 3 drops and 3 drops of warm organic colors. And I add 1 drop of black iron oxide. By the way, you should wipe the sticks periodically. Well, ideally after every mix, unless you're making something similar, so they stay clean when you stir. Otherwise, you might bring carbon into some nice lip shade, for example. So into 6 drops of organics, I just added 1 drop of black mineral. Very red, you see? Black iron oxide only slightly affected it. Okay, let's see what happens if we add white here. Kind of a dirty color, honestly, not the prettiest. So let's consider it unfinished. Okay, let's add 3 drops of white. Let's see what we got. Roughly. Already more interesting in color, and it blends more nicely. Still kind of not so pretty. Okay, I'll add 3 more drops of CI12477. Now the color became beautiful, now it can be fully spread. That's pretty much how I make colors in the lab, just in larger volumes. Look what came out. An interesting, deep, noble, and at the same time very covering color thanks to titanium dioxide. Cool, right? And without the dioxide, it was so transparent, non-covering. And at the same time, it turned out a bit cooler too, even though it was made from 2 very warm shades. That's because I added a little bit of carbon here. Oh wait, not carbon, but mineral. Black mineral. When we remove it with laser, it'll be clear what we're working with. And here we have 1 drop of black carbon. When you're experimenting, I also recommend labeling things so you know what's what. I already forgot what I mixed here. Well, never mind. Here I wanted to show how coverage changes. Here without dioxide, and here with dioxide. And here pure organics. Done, done. Yes, it's better to write it down right away so later it's not painfully confusing. So what else can we do here? Lip shades with minerals. Aha, let's set this color aside. Here we also have mineral, but literally 1 drop. And it doesn't really change much. I'll write it down now. 1 drop to 9 organics. And here we are now going to make a color that will have quite a lot of organic, and we're going to use this one here, for example, the red shade. Let's do 1, 2, 3. Then we'll add again, like 1, 2, 3. So this is my 14477 organic. And this is my mineral 77491. 3 drops and 3 drops. And then we'll also add some yellow here to lighten this color. We're just playing, right? That's how some lip pigments are made too. We'll add 3 drops of yellow mineral. Wipe the stick. Mix. Mix. Let's see what we got. Well, approximately here, into some kind of red color. Let's add some titanium dioxide because it's transparent. You see, I can even make a swatch brighter now so you can compare. Because here we don't have any titanium dioxide yet. Look, the covering properties ended right at the beginning, just so you understand, yes? So this is just some kind of tint color, even though there are both minerals and organics here, right? And at the same time, it's kind of transparent. Let's add a bit of blue too. We can do whatever we want, right? And let's add more red organic. 1, 2, 3. So now we've got 6 drops of yellow and red mineral. And we've got 6 drops of organic here, even 9 drops. Let's see what has changed now. There's a lot of organic and a lot of mineral here. So, well, almost 1 to 1. Let's take a look. The color is quite pretty, but kind of not covering. Let's add titanium dioxide again. Mix very well, because if you don't mix it thoroughly, the color will be unclear. It will separate. So really mix it, especially when you add black or white. Mix for a long time because it doesn't blend that easily. Because in industrial conditions, we, for example, run it several times through a dissolver. Sometimes it spins for hours. Some paints spin for days. And on top of that, there are many special manipulations to make the color come out. Now let's try making a swatch. You see the difference, right? How much more covering it became. It would cover any color underneath. And at the same time, beautiful. Look what an interesting shade it is. Brownish, pinkish, cool, noble. A very interesting shade came out. Beautiful. Too bad that I won't be able to repeat it. Or rather, I can repeat it visually. But in lab conditions, it's done differently. So here we have 6 drops of mineral, yellow and red. Here we have 3 drops of titanium dioxide. And we also have 1 drop of blue. And we've got something else. And black mineral, I think, right? You can't just write it down immediately. And 1 drop of black mineral. Ah, wait, we also have a bunch of organic here. 6 drops, I think, right? Ah, 9 drops. 9 drops of organic. Here I made the same mix, just with titanium dioxide. Okay, we'll also remove this later and see whether it turns gray from the laser or not. So let's make brow pigments once again. Last time we got it by accident, this time we'll do it consciously. And the color, it will be, well, let's decide as we go. Okay, let's start right away. Yellow organic, red organic, orange organic. Well, we won't use the cool red, carbon, and titanium dioxide. And let's also add mineral because mixes can be quite complex. We'll take 3 drops of each. 1, 2, 3. Because if I take less, the carbon will kill the whole color. 1, 2, 3. 1, 2, 3. Now, what else do I want to add here? Let's also throw in 3 drops of dioxide. I won't tell you the exact proportions of our real mixes, of course, because that's converged Scott plane, but you'll roughly understand how it's done. And 1 drop of carbon. You know what? Let's do this. I'll stir this up now. I'll show you the color that came out here. Mix it well. It's a very warm red-orange shade, almost like salmon, the kind used to correct unwanted lip colors. Such a bright orange, you see? And now we'll add 1 drop of carbon. Maybe 2, but first 1 tiny drop of carbon. And start mixing really well. Look, it instantly turned almost black. Let's see how it looks on paper. Nice, already looks good. You can even make a swatch. We got a brow pigment color. I'll dip a bit now. Well, it's pretty. I'd even call it a light brownish shade. But you know what? Let's add more warm organic. 1, 2, 3. Another 3. So here we had 3, 3, 3, 1, 3. I also wanted to add mineral. And to lighten it, let's add another 3 mineral. 2, 3, 4. So now we have plus red organic 3 more and mineral 3. Need to stir it. Don't forget to stir. This thing is addictive. You can just endlessly play with these pigments, creating shades. It's really fascinating, and then removing them with a laser, and you'll know exactly in which case what happens. The only thing I didn't add here is chromium dioxide, because we don't use chromium. It doesn't get removed by laser at all. It painfully lingers in the skin of clients for years. I don't recommend working with pigments that contain chromium, even if they're mineral ones supposedly designed not to redden. Look, it became an even warmer color now. Let's add, for example, some more yellow organic. 1, 2, 3. So that you understand how color gets removed when it's overly warmed up. Because I always encourage you to work with cooler shades, but to master technique rather than rely on overly warm pigments. Because when you are just starting your work, when you make a bunch of mistakes with shape, when you do some unattractive things with symmetry, later you will not be able to remove them. And that is bad. Your clients will not thank you. Look at this warm, light color we've got here. So practically from one set of colors, we can also create a huge number of different shades with varying degrees of warmth. And we will definitely remove this with a laser at the end, once everything dries. And as you've probably already understood, brow pigments made of pure organics don't exist. Lip pigments made of pure organics can exist, because if you mix these colors together in different proportions, you get such a light tint effect on the lips. Quite nice. If you add titanium dioxide, then it is no longer pure organics. It is considered not organic, and accordingly, the manufacturer can no longer say that his inks are pure organic. And without black, we cannot create any brow mix, because you will be forced to add either black mineral or carbon black. And accordingly, it will no longer be organic because those are inorganic pigments. Basically, that's it. I made several mixes. You can play endlessly with these colors, creating all these beautiful shades. You can also make swatches of other pigments, for example, the ones you work with, and compare with what you got. Meanwhile, I'll make a gradient of one of our lip colors. Which one is this? Rose. I have it here in industrial packaging. Oh, look what I've just done. That's exactly how it happens. Watch your hands carefully so as not to be a pig like me. And now we make a gradient of chestnut. I'm a fan of such beautiful, cool, noble colors that can be removed without any horrible inversion. That's why I'm for you working more professionally. Now I will show you all these colors. Zapped by a laser with both cold and warm tips. First, let's remove the monocolors. At least let's try. Right now I have a 1064 tip, which removes cold shades. I'll zap everywhere. The trick is that the black square underneath got removed, but the pigment itself didn't really react much. Carbon always removes beautifully. You see that, right? Orange organic usually doesn't react at all. The black underneath disappears. And organics don't care at all. White, look, doesn't turn green because we chose titanium dioxide that doesn't go green. This is an important point. Blue removes perfectly. Minerals also remove well, it's just that here the concentration is very high. I'll zap it at the end. As expected, minerals remove beautifully. Down to clean skin. Here we have a pure organic mix. Let's try removing it. With the cold tip, well, obviously no reaction. Here it reacts just a little bit. Here we had, by the way, titanium dioxide, so it reacts. It removed, look, immediately the dioxide. Oh, not titanium dioxide, this carbon. Right here, we had a bit of carbon, and it was immediately removed, and only that very warm mix of orange and yellow, which I had added here, remained. So here we also had a bit of black, and now the color of those shades appeared. That is exactly what I had done. Some of those paints. As soon as the black disappears, only the organics remain. Here with dioxide.
See them.
Also, there's no greening from the titanium dioxide, you see, none. None, right? You know, I don't remember what we mixed there, but let's click through them as well. The carbon is gone, only the organics remain. Look at what a cold color it was. Some kind of dirty purple-gray brown, right? And what a warm one it became because we just removed the carbon and it's not wet anymore. It kind of stains this color. So this is our mix where literally one drop was added to a huge amount of organics. There were like 15 or 16 drops and one drop of black carbon.
Very good.
Predictable. A terrible carrot color. It's unwearable. This is what I'm talking about. When the mix is too warm, after removal, we end up with these super bright orange-red brows. And living with them will be very hard for your client. Now, the next sheet we made, what do we have here? So black mineral. Here, 1 drop of black mineral to 9 drops of organics. Let's see what happens. Black mineral also removes perfectly. As you can see, organics remain. Organics remove with difficulty. You must understand this very well. Here we have 6 drops of mineral and 9 drops of organics. Practically no reaction, none at all. Here too, well, almost nothing is visible. There is some weak reaction, but very weak. Here, 9 drops of organics, 6 drops of mineral pigment, 3 drops of dioxide, 1 drop of blue, 1 drop of black mineral. Let's see how it removes. Where there is a lot of the pigment itself, usually almost no reaction is visible, simply because it takes it off layer by layer. But there's so much of it that it cannot remove it completely. That is, it goes back and forth many, many, many times. You understand, right? So possible, but simply where the concentration is lower, it's easier to do. Here, yellow organics 3 drops, red organics 3 drops, orange organics 3 drops, 1 carbon, 3 titanium dioxide, no mineral yet. It removes through orange, carbon destroyed immediately. Carbon removes just like a song. In the skin, it's as if it evaporates, really. Here we have the same thing, just plus 3 more red organics and plus mineral. Well, you see, right, what color turns out? The more warm color. Here I also later added yellow mineral, 3 drops, and added more organics. Just super. If you work with pigments that contain a lot of red and orange organic components, you must understand that they will be removed from your client through this kind of nasty orange color. Because on the eyebrows, such a color, of course, looks scary. This is our lip color. So, look, it doesn't get distorted. Even though it's muted, it doesn't shift into gray. Because if you work with a laser, you need to understand that minerals that are part of lip colors can be removed through gray. But by the way, not always. Something else has to be there. There must be a lot of titanium dioxide. When there is a lot of titanium dioxide, maybe we'll even make a mix with you now. This is how our brow pigment is removed. Compare. The difference is quite big. This one is straight orange, and this one is more yellow-brown. Wearable. Let's quickly do this now. We'll also pass through with the red tip. That's what I forgot to do. We'll make a color with a lot of titanium dioxide. Let's go 1, 2, 3, 4. And maybe it won't even work out because I initially use a titanium dioxide that is not that concentrated. Just so the pigments become more covering, but without being scary. Let's make it even lighter, because this color, look, if you make a swatch from it, many artists won't even realize that there is titanium dioxide in it since it looks bright enough. We'll add even more titanium dioxide so that it becomes muted. This is so you understand that those very light colors, the ones that really whiten the lips, are quite dangerous. Firstly, titanium dioxide will remain in the skin when the organic part fades away. Okay, let's add a bit more of this bright color. A very beautiful one, literally 1 drop, so the color stays bright. So actually, here titanium dioxide should be the first ingredient in the composition, because you can see how much I poured in here, but the color is still bright. Good. While it dries, we'll use the cold tip. Oh, I mean the 532 tip. I'll need to put on protective glasses. I hope my cameras can handle all this. So, and now we'll go over it here. Well, the red tip, I call it that way, removes organic pigments much better, so the reaction is much more interesting. I mean, I know there are special removal methods and all that. I'm not talking about laser removal. I'm talking about creating pigments that at least remove decently. At least they can be removed. Because just so you understand, I filtered out a huge number of pigments because there are really cool, beautiful organic colors that don't react to the laser at all. At all. Meaning, if you make a pigment, God forbid you make a mistake, it will be impossible to remove it. And that's what I'm always afraid of. So for all warm colors, the red tip works better by default. You see, right? Now we'll also try to remove these. They also get removed, quite well in fact. But so that you understand, I have the power set here in such a way that you are unlikely to use it on people. Well, it still turns a bit orangey, but it is also removed. I simply reduced it to the minimum value. So now I want to remove our colors. Return the power to what it was. It may even be removed down to clean paper. Well, here's our titanium dioxide. It doesn't even turn gray. Look, there is a lot of titanium dioxide here. If you look closely, there's a hint, but it doesn't gray out. There are just such paints that do turn gray. I don't know why manufacturers don't bother. Probably none of the manufacturers think their paints will ever need to be removed. That's the trick. Probably because these paints are simply just tattoo inks that artists pour into small bottles, and that's it. And paints created specifically for permanent makeup, for the possibility that beginners work with them, they must be removable. That is, the manufacturer should think that these paints must be removed more or less easily, despite all these features. I was concerned. I searched for a supplier who would give me paints that can be removed. By the way, about correct and incorrect removal. Look, here the grayness appeared when I went over it with a cold tip. Let's check again. It's interesting. Yes, there's clearly visible grayness on the dense part. This is how clients end up with gray lips, because artists apparently remove them incorrectly. Strange, why touch lips at all? Well, anyway, I'm not a specialist in laser removal, that's for Vitalik Mikrikov, but you should understand that the same color here with a lot of titanium dioxide, when working with a gray tip, well, I mean the 1064 tip, it can give a slight grayness. When working with a warm tip, there is no grayness at all. Everything is removed perfectly. So now we will also play with dry paints. We have 3 colors. We will try to create something from dry powder and generally see what dry paints are. Of course, I cannot give you all the colors because there are actually an incredible number of them. But we will try these liquids that go as a base, as a foundation. So what is this? Black, carbon black. I pour out just a tiny bit, just a gram. Look, just so you understand what it is. I simply rub it with my finger. So this is what it's like. In fact, if you rub it and look at it strongly under a microscope, you will understand that it's not some sort of dust, but some lumps. And so you understand this raw material comes to us in granules. That is, when the manufacturer sends us dry powder to the lab, He granulates it specially, because if you open just a bag of carbon that is not in agglomerates, but just as it is originally, when it is created directly from gas, then it will just disperse into a cloud. It won't wash off. It cannot be collected. It's very volatile. It's incredibly difficult. And right here you can try, for example, yes, take a little capsule, put some of it inside, carbon, and drip in, well, for example, water. All of these liquids drop by drop and try to mix it. For example, a couple of drops of water. Look how interesting. It ran away. The drop of water stayed in the middle, and the carbon ran away from it. Because carbon does not mix with water, just so you understand. That's the kind of drum dancing we do in the laboratory to mix it, to make it liquid. So, and we'll add a couple of drops of glycerin. Oh, what's that? Propylene glycol. And a couple of drops of glycerin. Of course. There are also alcohols and all sorts of things like that, which we didn't put in the kit because it's unnecessary stuff for playing. And let's try to mix it. And let's try to compare it with our black that has already been mixed in the laboratory. Looks like something got mixed there, right, in the end? Let's see. I poured everything out, poured everything in. Well, that's what came out. If you stir it like this, you'll understand it yourself. It kind of squeaks inside. That is, it didn't open up. This color didn't open up at all because it's impossible to do outside laboratory conditions. Okay, I take our real carbon. What a difference. Right? In the quality of the stretch, in the fact that it spreads out very evenly. It's kind of oily, sort of nice. It's very black. This is our very covering, beautiful color. So that's 2 carbons. Next, we have red organic, an incredibly beautiful color as well. I'll take a drop with the remaining finger. Just like this, feel it by touch. It's like sand. Organics are also very sticky, very volatile, crumbly. It's just like some kind of suspension in the air, then all the floors are red, all the walls are red. And we work in the laboratory in special fume cupboards in which all this dust flies away during mixing. Look here, the organics look exactly like sand. If you press it down like this, rub it, then a bit of the color appears. Let's also try to mix it. We'll also add water, a couple of drops of glycerin, and a couple of drops of propylene glycol. Actually, our mixes have a more complex composition. We even add hyaluronic acid so that the pigment becomes even more friendly to the skin. This gives amazing results when implanted. And let's try to mix it. Will this color open up? We have the same color here. So this is number 12-466. And here it is already diluted in the laboratory. Now let's make a swatch and compare. Okay, I stir it really well, soak it well, and make a stretch. Well, it looks cool, right? Beautiful color. And I take the exact same color so that it soaks well into the stick as well. And make a stretch. Look, it even has a different shade. This is pure, the same color, but so you understand, when the shade properly opens up under laboratory conditions, it changes very much. Because all of these agglomerates are evenly ground in the mill. And often the colors become much warmer, more beautiful, more opaque. Because this is the same color that I just randomly mixed dry in the capsule, and the one that has been revealed for you in the laboratory. So black iron oxide, and you can have a lot of fun with it too. So look, first of all, if you pour it out and rub it, it even seems to look more covering, although of course it is not. And here the most fun thing is to play with a magnet. Look what beauty you get. Look, here's an agglomerate lying there. Now it will flatten. It seems as if the pigment is rubbed right into the paper, but it isn't. This is real magic. What else can you do? You can pour, for example, carbon into water. And also play with this magic when it moves around like it's alive. Just like it's alive. Look how interesting it is. Here's the mineral color. Look, I drop it, already diluted, and here it starts to gather too, as if it's separated from the liquid, and now it follows the water in the glass. In the capsule, it looks cooler, but still, well, I can probably even collect it here with a magnet. Can I? Yes, it gathers. Well, not as well as I would like. I thought it would be possible to completely clean the paper. Imagine how cool that would be. Now it can only be washed off because it sticks firmly. That's how you can play with it. And basically, if you buy some paints and are not sure that they are really mineral paints, then you have two ways to check. First, magnetize them. And the bottle must definitely be magnetized. Because here, the black mineral, look, it's magnetized. In a mix of mineral pigment, there must always be black mineral. If your pigment doesn't magnetize, then the manufacturers lied to you. And second, you can remove it with a laser, because pure minerals are removed with a laser down to clean paper, down to clean skin. And that's exactly why I recommend all beginners to work with mineral paints, because they forgive many mistakes. They lay down softly, they don't create harsh outlines, it's harder to go too deep with them. And if you still made some not very nice asymmetric work, for example, and you want to remove something, you will remove them down to clean skin for your client without any problem, unlike organic or hybrid paints. That's basically everything I wanted to tell and show you. Write to me, send me your videos, your mixes that you've made, anything interesting you come up with. Tag me in all social networks. I'll be happy to watch and maybe take some of your most beautiful color developments into use in the laboratory. That's it. Bye, everyone. We're finished here.